All right, so this is an Algebra 1 challenge problem. It's two trains meet. One travels from Rock City to Gnome City, and the other travels from Gnome City to Rock City. So we have a train, which we'll call train number 1, leaves Rock City at an average speed of 50 miles per hour and heads for Gnome City. Another train, which we'll call train 2, travels to Gnome City at an average speed of 40 miles per hour and heads for Rock City. If the route is 360 miles long, how many hours will it take for the two trains to meet? I'm going to highlight hours because we want to make sure that we're solving for the right variable in this problem. We'll be solving for a couple. We want to know that for the final answer, we have it in the right terms and we've solved for the right variable. So here we have our little description. So we've got train number 1, which is in blue down here, traveling from Rock City to Gnome City at 50 miles per hour. Then we have train number 2, which is traveling from Gnome City to Rock City at 40 miles per hour. It's written up there. And we know that the distance from the two cities is 360 miles. So they're traveling the same route, so they'll meet somewhere in the middle, but not quite in the middle because one train is traveling a little bit faster than the other. So we're going to think they're meeting right about here. This is where the trains meet. And because they're traveling different speeds, this distance will be different from this distance. We'll call the distance that train 2 is going x, and the distance that train 1 goes 360 minus x. All right. So we know that they're traveling different speeds, but we do know that they start traveling at the same time. So when they meet, they'll have both been traveling the same amount of hours. So we have a little bit of description here. Both trains will have been traveling the same amount of time when they meet. Therefore, time traveled by train number 1 will equal time traveled by train number 2. We have our formula distance equals speed times time. So let's start with train number 1. So we have train number 1. Distance of train number 1 is written right here, 360 minus x. We have 360 minus x. This is when they'll be meeting. It's going to be equal to speed, 50 miles per hour, times time, which we don't know yet. So now we'll do train number 2. So we have train number 2 traveling 40 miles per hour, and the distance will be x, 40 miles per hour for speed. And we have times time of train 2. All right, so we know that T1 and T2 are going to be the same, so we can set these equations equal to each other. But we'll have to do a little bit of moving around first because we want to get T by itself on one side of the equal sign. So we're going to divide both sides of this equation by 50 because we're multiplying by 50 on the right side of that equation. Divide both sides by 50. We'll get 360 minus x over 50 equals T1 because these two 50s cancel. All right, and then for train number 2, we're going to divide both sides by 40, doing the same thing that we did on the other side. These 40s cancel, and we're left with x over 40 equals T2. All right, so now we've got the t's by itself, so we can set these two sides equal to each other. We'll have 360 minus x equals 50, or over 50, equals x over 40. So we can set these two equal to each other. All right, and now we solve for x by cross multiplying here. It's a good thing to look for when we're setting two fractions equal to each other that we'll be cross multiplying. So we have 4 times 360 minus x on one side, 40, is equal to 50x on the other side. So we'll multiply this, distribute the 4d, then we'll get 14,400 minus 40x equals 50x. Then solve for x, we add 40 to both sides. And then we get left with 14,400 is equal to 90x. We'll divide both sides by 90 to solve for x, and we get 160 equals x. So now this is not our hours, this is our distance, if you remember. So we'll have to go back up here. We have x, which we find right here. This equals 160. That'll be in miles. So now we have to figure out how to find time. So we have the distance basically that train number 2 traveled. We have from here to here, that's 160. So we can write 160 equals speed of that train, which was 40 miles per hour, times time. So we'll solve for that time by dividing both sides by 40, and we get 4 equals time. So the trains will have been traveling for 4 hours when they meet. All right, thanks for listening.